Okay, I wanted to work a little small version of a problem that I'm assigning for homework so you'll understand exactly how I'm wanting you to fill out this table. Okay, so here's the problem. We have this little bitty series circuit where we just have A, B, and C connected in series. I've shown some voltages here, I've shown a current, and I want to fill out this table that involves the power calculations for the circuit. All right, so I'm looking here, and the thing that I don't know, I know the current through all the elements, I know the voltage across A, and I know the voltage across C. The thing I don't know is VB. All right, so I can write a KCL equation around a loop. All right, so we'll start in this bottom corner here and go around this loop. Okay, so when I do that, I get a rise of 30 volts, and then I get another rise of VB, and moving around this way, and then I get a drop of VC, which is 10. Okay, so that lets me solve for VB, and I intentionally reference this to where VB would turn out to be negative. All right, that's okay. We can still interpret that. All right, so I fill out my chart here, and I know that the voltage for A, that was given as 30 volts. The current was given as 3. All right, the voltage for B is minus 20 volts because that's what I just calculated. All right, the current is 3. The voltage for VC is 10 as it's shown here. All right, positive 10. And the current is 3. All right, so that lets me calculate the powers. I just V times I, 90, minus 60, and 30. Okay, now I look at the sign conventions. All right, and so what I'm wanting here is A for active and P for passive. All right, so I look at the sign convention for A. All right, so let me clean this up a little bit. For A, if I'm looking at current is moving in this direction. Okay, so as I move in this direction, the direction that current is referenced in, it's a voltage rise. Okay, so that's the active sign convention. All right, for B, current is moving in the direction of a rise. So once again, that's the active sign convention. And then finally for C, current is moving in the direction of a voltage drop from plus to minus. All right, so this is the passive sign convention. Okay, so at that point, we're able to interpret the power, whether in terms of whether it's using power or supplying power to the circuit. Okay, so on the first one, since we have 90 and it's active, then our conclusion is this is 90 watts supplied to the circuit. Okay, and then the next one, we have a minus 60, but it's an active sign convention, so the minus, if it had been a positive number, it would have been supplying power to the circuit. Because it's a negative number, that flips our interpretation, and so we would say this is 60 watts using. All right, and then finally the last one, positive 30, passive sign convention, it's 30 watts using. And then conservation of energy and power suggests that the supplied should equal the used. All right, and so we can verify that 90 watts is supplied, and then 60 plus 30, which is 90, is used. Okay, so I want you to do this for a larger problem. Okay, so here's the problem that I'm going to assign for homework, and you should go through that and figure out the unknown voltages, figure out unknown currents, fill in the chart, determine the sign convention, and then interpret the power. All right, so there'll be an exam problem like this, so it's worth putting your time in so that you'll know how to do this exam problem. It's an easy kind of problem, but I think it tells a lot because it covers KVL, it covers KCL, It covers power and sign conventions and a lot of things that help you get started on your way to learning how to analyze circuits.